Let me make sure. Okay. All right. Here we go. We're going to go ahead and get started. So, good evening and welcome to this evening's presentation. My name is Judy Kitt. I'm the president of the Foundation for Mind Being Research, and I know we have a few new people here this evening. So just briefly, I want to let you know that FMBR was founded 41 years ago now, in 1980, by scientists and artists and healers who were really interested in studying human consciousness through the lens of science and ancient wisdom traditions and spirituality. That sweet spot that we're kind of talking about tonight. So I encourage you to check us out. We're at fmbr.org. We also have a YouTube channel. If you go to YouTube, it's FMBR TV, and I encourage you to subscribe. And I'm told that if you click on the little bell on that page, you'll be notified when we're going live. So we're really honored to welcome Shelli, Renee, Joye to speak with us this evening. Shelli is a best-selling author of several books, including The Electromagnetic Brain, which just came out last year, and Developing Supersensible Perception, which came out in 2019. She has a bachelor's degree in electrical engineering, a master's degree in Indian philosophy, which is a fantastic combination, and a PhD in philosophy, cosmology, and consciousness from the California Institute of Integral Studies. She's an accomplished painter and musician, playing the piano and accordion. She lives in a cedar cabin in the lower Cascade Mountains of eastern Shasta County in Northern California. And not too long ago, she had to evacuate due to the threat of fire. And thankfully, she's all right. But now that she's back and she's here with us tonight, and her the internet connection there is it fluctuates a bit. So we decided that it's best, it works best to see her slides if her camera is off. So she's gonna keep the camera off so that we can get a flow on the slides. So just so you know that. So Shelli, welcome. We're so glad to have you here this evening. Shelli, can you hear me?
Well, yeah. Can you hear me?
Yes.
Okay. I got a little note said my internet connection is unstable. So
okay, we'll see how it goes.
I live up in the mountains and have a very, we'll do the best we can.
Okay.
I'm really happy to be able to present these ideas. And it's about something that we all share and experience every day. It's called consciousness. And even when we sleep and dream, we're experiencing a mode of consciousness. So it's pretty much a 24/7 experience that's still a mystery. 10 years ago, I completed all my coursework and passed my candidacy exam for a PhD in consciousness studies. And I moved up here with my books to do research into how modern scientists have approached completely new theories about how consciousness works in the universe. My original academic degree was electrical communication engineering. Since the age of 12, I have had an amateur radio station and still do. I enjoyed reaching out to other parts of the earth using waves that we call radio. But I also, and in particularly what is called now transpersonal psychology, which deals with such reported things as telepathy, healing, and other unusual but widely reported phenomena. And they are related to consciousness, but I also loved science fiction as a kid, so it all kinds of ties into my final PhD program. I entered my doctoral program in 2010 and completed it in 2016. And this presentation will be essentially a description of what I discovered during my years of doctoral research. My dissertation focused upon a theory called the Pribram-Bohm holoflux theory of consciousness, which will be the primary focus of this presentation. Some of the slides may be a bit technical, but I'll try to explain the ideas in clear terms. And in a week, this presentation will be available on the website of the Foundation for Mind Being Research. And you'll be able to go back and examine the slides that may have seemed mysterious at first in encounter. It points to one single underlying transcendent consciousness that fills every dimension of the universe and projects itself into space and time. This theory can be shown to be supported both by cosmology, which is the structure of the universe, and by both quantum physics and brain science. Of course, my own background in electrical engineering has put a spin on the theory that is my own contribution to what is called speculative science. I also believe the theory offers the science and physics behind the realities taught by many religions and backed by the mystical experiences of saints throughout history in many cultures. But that's a topic for another, perhaps longer presentation. A big takeaway of this theory is that the mind works through modulated electromagnetic fields, and that it is not limited to the neuronal wiring in the brain. The brain itself instead acts more like a laptop computer that is used by the electromagnetic fields that are the mind. If this is true, then it is possible that the brain is tunable, using electromagnetic fields to filter and connect with a wide range of conscious dimensions, and possibly to link with bands and networks of communication that have yet to be revealed to modern science. Yet, possibly linking to these other dimensions of consciousness has been the practice of generations of saints and mystics, both in the West and in Asia. Here you can see an infrared image of a human glowing in the dark at different frequencies. The different colors and the temperature chart on the right map the different intensities of energy at different frequencies. In the human, these major energy sources are what we call in the infrared bandwidth. Most people and even many scientists sort of dismiss this as heat, the simple word heat, but they're actually electromagnetic radiation energies. Now to the main topic of my presentation, which is cybernetics. In 1947, Norbert Wiener published Cybernetics, or Control and Communication in Animal and Machine. He chose the word cybernetics because it was a Greek word for steersman. And he was working during the war to develop methods of controlling aircraft, anti-aircraft guns, using radio waves, radar, and actually one of the first computer systems. Here you can see that the output of the aiming the guns, they're controlled by radar. So it's a complete loop. There are a lot of other examples of cybernetics. A few might be, there's an ancient symbol in medieval alchemy of the Ouroboros. Ouroboros is a snake biting its tail. Something that's more familiar to most of us is the mechanical loop of our heating system, or our AC systems. As we measure the temperature going up or down, it adjusts our heater or our AC to try to maintain a certain controlled temperature. Biologically, our human systems have all kinds of cybernetic loops. And the most obvious one is the one that keeps us cooler when we sweat. And when we get cold, we start shivering to raise the temperature of our body. Now I'd like to talk about the two main scientists who my work has been based upon. Karl Pribram, who died 4 years ago at the age of 95, and David Bohm. Together they developed a very interesting theory, and they both became very interested in consciousness also, which was rather unique at the time for scientists. Karl Pribram passed away in 2015 at the age of 95. At the age of 21, he graduated with an MD in neurosurgery from the University of Chicago. He was quite a brilliant guy. He wrote over 180 papers and many books and spent many years at Stanford, retiring as an emeritus professor. He contributed to teach and lecture even well into his 90s. And his final book, perhaps one of his best, I thought, because it's easy to understand without a lot of scientific background, he published it when he was 93. I could only wish I'll be able to even read when I reach 93. But it's an amazing 650-page account of consciousness research. He calls it The Form Within. His lifelong search for the location of memory led to his conclusion that memories are stored not within specific locations in the brain, but as holograms in what he called the frequency domain, as holoflux or holograms. And he said in the form within, holograms are examples of spectra, that is, of holoflux. Since the 1940s, he had carried out experiments searching for the mysterious engram, the location of memory storage within the brain. In fact, a lot of research had gone into that since the 1930s, but nobody was able to discover a specific location for any specific memory in the brain of either humans or monkeys. Since the 1930s, various laboratory experiments tried to discover the location of these memories. And for a long time, before the practice was outlawed, they would remove various portions of the monkey brains to see if the monkeys would lose the memories that they had acquired after they were trained to carry out tasks. But no matter how much brain matter was removed, the monkeys always remembered what they had learned. After years of research, Karl published his holonomic brain theory. In a long series of experiments, he discovered three-dimensional electric fields within the spatial volume of the dendritic webs of cerebral cortex. You can see them to the right. In fact, most people don't realize it when they hear about the cerebral cortex covering the brain, but it's thinner than a sheet of paper. But within that sheet are tiny, tiny felt-like webs of neurons, which he believes contain holographic fields operating in three-dimensional electromagnetic, ever-changing processes. And he felt that they were fundamental in both memory and in perception. The implications are that consciousness, the experience itself, is not a function of nerve impulses flowing between neurons, as shown in this picture. What he did was he tried to map the voltages in the brain, in the cerebral cortex. It was very, very time-consuming and painstaking, but he mapped similar voltage levels and found that they created patterns, a contour map. He called these maps holoscape contours. So as you can see, these might be a certain voltage, all these little red dots, and a slightly higher voltage might be the green ones. So they created what looked like fractal or holographic patterns. In fact, holographic patterns are also the nature of electromagnetic fields. In the mid-1960s, he read a paper on holograms and holographic images, and he immediately noticed how the holographic patterns were very similar to what he had found when he was mapping the brain with a holoscape. So what is holography? Well, the mathematics of holography is made possible by what's called the Fourier transform. It's a mathematical relationship between pure frequencies on one side and space-time on the other side. Fourier transform holography encodes objects as information, as interference patterns. And you can see that the pictures of the Queen are actually in the holograph. You really can't perceive them. Actually, David Bohm, who we'll talk about later, said, if our eyes didn't have lenses, he is sure we would see the universe as an enormous holograph. So what is the Fourier transform? Well, it was discovered almost 200 years ago. It's a pure mathematical equation or relationship. Some people call it a bridge. In 1822, Fourier, who was Napoleon's governor of Egypt at the time, and also a prominent mathematician from Paris, discovered an equation that perfectly models the flow of energy between two domains. He discovered his equation while trying to solve the mathematical problems involving heating up metal for cannons for Napoleon's armies. The Fourier equation on the left transforms information from the frequency domain. This is the frequency domain. The D means delta. Whoops, I got to go back one. The frequency domain, I keep clicking here, to the time domain. So that's the time domain. A function of the time domain is equal to this Fourier transform of the frequency domain. And on the other side, it shows that information from the time domain, which we live in, time and space, can be perfectly modeled in the frequency domain. And I'll try to explain this later, but it's probably one of the more difficult things to learn in electrical engineering. So this is the diagram published for a transform. As you can see in the center is the Fourier transform. Space-time is on the right, and a spectral frequency domain is on the left. And Dirac's diagram shows that all of this Fourier transforming actually happens in nature at what is called the Planck's constant down here. And that's at a very, very, very small dimensions. So Karl Pribram thought that, well, maybe memories, since they can't find them in the brain in a specific location in space, maybe they're stored by Fourier transform data in the frequency domain. And this has always been a problem for mathematicians. A lot of mathematicians agonize over what is more real, the universe that we see or mathematics. So many mathematicians, in fact, I think mathematicians have one of the highest suicide rates in the world, or they used to, because they ponder these things. But the ontology is very real to Karl Pribram and to David Bohm. So I'll talk a little bit later about string theory and how the space-time domain is only 4 dimensions of a possible 10 or 11 dimensions. The Fourier the mathematics of the time domain is extremely complicated, as everything is in our space-time universe. And to solve very complex calculations in electrical engineering, it was found that by first converting the equations out of the time domain into the frequency domain would make solving the calculations extremely simple, because within the frequency domain, the math is very straightforward algebra. Thus, even to this day, engineers almost always use the mathematics of the Fourier transform in order to solve complex design problems. The Fourier transform makes it relatively easy to move back and forth between the 2 domains. Here's a real-world example of the Fourier transform that might make more sense. In this example, we see an engineering application. Incoming music is detected by a microphone at the left. At regular intervals, the acoustic wave is sliced by a frequency splitter into 16 unique frequencies recorded and saved, often saved digitally, and transmitted. It's either transmitted or stored for later replaying. Thus, the incoming space-time music has been converted to the spectral data using the Fourier transform. The frequency data of the music is then later unpacked and mixed, and then it emerges from an amplifier and a speaker in space and time in acoustic waves, once more in space and time. And if we're near it, we hear it. Pribram's theory says that the energy of consciousness operates in a somewhat similar fashion, transforming memory information continually between the 2 domains. Memory is a holographic projection of 3D electromagnetic fields in the brain. After several years of working with David Bohm, in fact, Pribram proposed that information itself is stored within Bohm's implicate order, also called the frequency domain, and that the Fourier transform is something that's continually working within our brain-mind system. Pribram and Bohm, the quantum physicist and the brain scientist, had become close friends over 2 decades of technical discussion. This picture shows David Bohm and Karl Pribram dining out in Prague. It was taken shortly before Bohm's death in 1992. So who was David Bohm? Well, he was an American physicist who grew up in the Midwest. Well, not actually. He grew up in Pennsylvania. At Princeton in the late 1940s, Bohm became a good friend of Albert Einstein. They happened to live in the same faculty apartment complex. Einstein became his mentor, and they corresponded for the rest of Einstein's life. What made both of them different than many scientists and physicists is that they complain that many physicists only use mathematics and physics to try to solve problems and not to try to understand the reality underlying the physics. So the reality of underlying things is called in philosophy ontology. Ontology is trying to understand what's really going on, what's the underlying reality of things. And actually, Bohm had been going to Stanford as an undergraduate student and then a graduate student for a while, but he was really discouraged. All they wanted to do was solve problems with mathematics. They didn't care what was really happening underneath, or at least that wasn't a major thing of inquiry. But later in life, Bohm became fascinated with the physics of consciousness itself, and he met with a number of highly regarded religious leaders to share his ideas. Here you can see him with the Dalai Lama, the Tibetan Dalai Lama in 1980. Bohm began his career with a fascination for what is called plasma. Plasma is one of the four fundamental states of matter. The others are solid, liquid, and gas. And plasma appears when electromagnetic fields interact with ionized gas molecules and atoms. This is a picture of a plasma ball lamp, actually. They were quite popular back in the 1960s among hippies when I was a kid. The glowing tendrils of plasma move in strange and ever-changing patterns. Plasma constitutes over 99% of the matter of the universe, something I didn't realize till I began studying the whole thing. It's the primary constituent of cosmological structures, such as stars and gas clouds. So basically our star, our sun, is a plasma. Here's a Hubble photograph of a vast intergalactic plasma cloud in Andromeda. It is out of such plasma that new stars begin to form. But Bohm's biographer, David Peat, tells us that, quote, as Bohm studied the plasma, he became struck by their extraordinary nature. The plasma began to take on for him the qualities of living beings. Here's a picture of a plasma in the laboratory. When Bohm introduced an electrical probe into the plasma, a charged sheath would immediately form around the probe and neutralize itself, as if the plasma were protecting itself. At one point, Bohm suffered several weeks of a nervous depression, during which he came up with a new understanding of the physics of plasma. And he decided to make this the subject of his PhD dissertation. To Oppenheimer's surprise, Oppenheimer was his graduate committee chair. And Oppenheimer, of course, was working on trying to develop a nuclear bomb. This was all during the war, World War II. Bohm put forth an entirely new theory of the plasma state, supported with a mathematical model. And his discovery was immediately put to use by Oppenheimer's team to separate U-235 from U-238, something they had been trying to do. And this led to the first atomic bomb explosion, actually. Here's a picture of a hydrogen bomb test in Nevada in the early 50s. This picture is taken from 20 miles away, and it's 1/500th second after ignition. And what you see is pure plasma. Unfortunately, Bohm did such a good job, let no good deed go unpunished, that his dissertation was classified top secret. And it was only with a lot of arguing that Oppenheimer was able to persuade the regents of the University of California to grant Bohm a doctorate degree without first publishing his dissertation, which now is top secret. I thought that was kind of amusing. I don't think Bohm thought it was amusing, though. 25 years after writing quantum theory, this is a book he wrote 4 or 5 years after getting his PhD. This book actually became a standard textbook on quantum theory for the next decade. But Bohm had arrived at the conviction that the universe consists of two distinct domains or regions. He called them an implicate order and an explicate order. According to the physics of what is called string theory, the universe is composed of 11 distinctly different dimensions, of which space has 3 and time has 1. So basically, we live in what is a 4-dimensional world, if you don't count consciousness, because they don't really understand talk about. But experiments point to the existence of another 7 dimensions beyond space and time. And this came out of mathematics, which was trying to understand the results of linear ion accelerator data, smashing ions and protons together, and very strange particles would come out at unusual angles. And they used the mathematics, very advanced calculus, to try to predict next time what's going to come out. And the only way they could come up with a reason why these things happened was that there must be 7 more dimensions beyond space and time. So Bohm said that something he called the implicate order was where these other 7 dimensions were rolled up. Bohm based his hypothesis upon 2 fundamental constants. These were first discovered by the father of quantum mechanics, Max Planck, in the year 1900. What are these Planck constants? Well, the values were determined by Planck and published in this famous paper in 1900, which constants of the universe, including the speed of light and the gravitational constant, to calculate the values of the Planck length and the Planck time. These are really, really, really small. They're so small that they're at the bottom of space, and the bottom slides that explain that. What they imply is that both time and space are granular, that time and space are not, as we often assume, continuous, like a continuous line tracking something moving. Bohm even said that as an electron moves, it flashes in and out of time and space. So it's almost like your video Netflix screen. Nothing is continuous. Everything is pixels, and because they're so small, your brain, which can't see that small, connects it for you. It kind of distorts it by making it look continuous. Here's another metaphorical view to examine the Planck length. In this context of an image provided by Dr. Bernard Carr, professor of mathematics and astronomy at the University of London, where Bohm taught. In Carr's diagram, we see the head of a snake swallowing its tail, kind of like one of those first slides. The body of the snake represents the entire spatial scale of the universe here, from the diameter of the universe just behind the head, and then moving counterclockwise to smaller dimensions, all the way down to the Planck length at the tail of the snake. Starting at the head, we shrink in scale, moving from the outer universe through galactic clusters and galaxies to planets, mountains, molecules, electrons, down through atoms, viruses. And finally, there's a desert. You see that, if I can click this without moving to the next slide, this is the desert. This is where our scientific instruments cannot yet go. And so we really don't know what's happening down there. But we do know the very bottom of it is the Planck length. Now let's grasp the snake by the head and pull it down from the tail, and we'll have another view. So here's another view where at the very top is the diameter of the universe, 10 to the 25 meters. And of course, the universe is still expanding at the speed of light. But it's approximately 10 to the 25th meters in diameter. As you get smaller, we move down to the diameter of the Milky Way, 10 to the 20th, the diameter of Earth's orbit, 10 to the 11th meters. Our human dimensions, I put 10 to the 0. That would actually be 1 meter, I believe, like 3 feet. So it'd be about the size of a 5 or 6 year old, maybe. And as we get smaller and smaller, here's 10 to the minus 11, hydrogen atom radius, 10 to the minus 17 would be an electron. It's even smaller than a hydrogen atom. And at the very bottom of space is the Planck length, which you can't go below because space doesn't exist below the Planck length. So 10 to the minus 35 is the Bohm talked about. Here's another way, another metaphor, diagram showing an ocean. The dimensional scale of space between an ocean surface, where we exist at the top. I show the wingspan of a butterfly, 10 to the 1 centimeter. And the bottom of the ocean, the very bottom, is the Planck length where space ends. And the implicate order begins. To better understand starting at the outer limit of the universe, which is constantly expanding, we'll focus on the outermost shell of the universe. Now you begin moving inward toward a geometric center, and you pass through, my slide wants to take off on itself. We assume that each shell has a smaller dimension until you reach the very tiny center in the middle. When you reach the very center, you've reached the Planck length. And you have to think of a sphere, a little sphere, think of a tiny micro black hole. And the diameter of that sphere would be the Planck length. So we know that anything smaller than the Planck length doesn't exist in time. Therefore, if you have a sphere and the diameter is the Planck length, inside that sphere is the implicate order. So here's another example of a proton at 10 to the minus 15th. Inside that is a Higgs boson, 10 to the minus 17, and an electron at 10 to the minus 16th. And you keep getting much, much smaller, and you get down to 10 to the minus 35. It's almost unimaginably small, but it exists. And below it, there is no space. So here's a spatial diagram showing at the very center, the 10 to the minus 33 centimeter Planck length, where the implicate order resides. And then outside of that sphere is our space-time universe. So here we have a timing diagram. Now this is the other Planck constant. So this shows the smallest granular measure of time. Time itself is not linear. In fact, we pretty much have an idea of that now because we're all familiar with digital electronics and digital clocks for our laptops and our computers. The Planck time constant, which I showed a little while ago, is 10 to the minus 44 seconds. And physicists believe that you can't measure time as anything smaller than that. So this shows a clock cycle where each cycle is 10 to the 44 hertz, or 10 to the 44 seconds. And Bohm's existence at 10 to the 44 times a second. That's an incredibly fast, so fast that we think that everything is smooth and linear. And this was a metaphor by someone named John Wheeler, who was the discoverer of black holes. And he called it the self-observing you. He felt that the universe was all connected and that somehow the universe was looking at itself as it was creating itself. And this is a really nice symbol that fits into the theory that I'm talking about, that there is a cybernetic connection to the whole universe. There is a loop, and that the universe, you might even call it God, is watching itself, watching himself, watching his own creation. So what we're doing is trying to talk about some of the physics and geometry of maybe modeling a little bit of what God is doing in creating the universe. So I don't want to go there. I'm a heretic somehow. I try not to bring any religion into this. But pure physics and science really should support everything that is real about the ideas, which I've already mentioned, that go far to explain mathematically many of the strange results from the Large Hadron Particle Accelerator experiments, are string theory and M theory. And followers of string theory predict that there are 10 dimensions that make up reality, while followers of M theory predict there are 11 dimensions. In fact, M theory, no one is sure where the word M, the letter M comes from, but some people think that the first people who came up with theory. So whether there's 10 or 11, there may be more. Actually, Bohm thought there may be many more dimensions, but that's another story. So going back to the tiny black holes, or the holospheres at the bottom of space, Bohm also conjectured that there were many of these, and not just one center to the universe. There were innumerable centers to the universe. And so that at the very bottom of space, there's what's called a plenum, P-L-E-N-U-M. Actually, the plenum was something that was a core belief of 19th century physics and philosophy. Bohm wrote that what we the plenum, which is the ground for the existence of everything, including ourselves. The things that appear to our senses are derivative forms. Their true meanings are generated and sustained, and into which they must ultimately vanish. Of course, Bohm had become fascinated with the mystery of consciousness itself, and he wondered how could physics explain consciousness. At the time, this was a question almost no scientist was willing to ask for fear of ridicule and loss of status. At the time, the subject of consciousness was left to religious philosophy and mystics, who, of course, knew very little about physics. But I guess our task in this 21st century is to unite science and religion in a view that really makes sense. So, of course, things have changed, and recently there are many departments of consciousness studies themselves throughout the United States and the world. Although not a lot of scientists go into studying consciousness because there's not a lot of money for research in it. But that made chair of theoretical physics at the University of London, David Bohm, and philosopher and mystic J. Krishnamurti. The two hit it off and began meeting regularly in public over the next 24 years. Krishnamurti was really fascinated with physics and wanted to learn more about quantum. Krishnamurti's understanding of direct experience of mystical states of consciousness and observation in the human mind, especially in the relationship of the observer and the observed. This is a big thing in physics because there's a lot of arguments about whether the observer in an experiment affects the experiment and the universe is interconnected, then definitely there must be some connection. I think there's something called the butterfly theory where some people say if a butterfly flaps its wings in Massachusetts, it'll cause the weather to change in China. But I don't think that can be proved, but it's somebody's idea. In other words, how does the observer affect what is observed? Bohm first met with Krishnamurti in 1959. He said, here's a quote from him, "My first acquaintance with Krishnamurti's work was in 1959 when I read his book, The First and Last Freedom. What particularly aroused my interest was his deep insight into the question of the observer and the observed. The question had been long close to the center of my own work as a theoretical physicist who was primarily interested in the meaning of the quantum theory. But 30 years later, and now chair of theoretical physics at the University of London, Bohm writes, let me propose that consciousness is basically in the implicate order. So what does Bohm mean by consciousness being in the implicate order? Well, here we have overlaid the image of an iris over at the left at the boundary line of the implicate-explicate order. It indicates that the observer may be looking out from the implicate order into our local time-space universe, the explicate of the non-local implicate order. You might think of it from religious terms as God projecting the universe out into space and time, and also looking at it. This is the scientific view that has been developed by Pribram and Bohm. However, we can also find many Asian mystics who have come up with a very similar view, though not expressed in modern terms of quantum physics for sure. Here's one of them. At the bottom now, you can see his name is Vachaspati Mishra. In the 9th century, he wrote that it is Purusha and not the mind, our empirical sense of self, that sees this knowledge. In this view, the single non-dual Purusha, which could be our soul, our transcendent soul in these other dimensions, is peering out from those implicate order frequency domains into the world of space-time, the mind at the right. So transcendent self-awareness is looking at immanent self-awareness and also projecting it. So somewhere here is a cybernetic loop, which I'll get to. The Pribram-Bohm hypothesis basically said we found where space ends, at the center everywhere, below the Planck length. Consciousness resonates between these two domains, and that in the implicate order is what he calls the self. Actually, Carl Jung used to talk a lot. The great psychiatrist talked about the self with a capital S, that there's one self somehow at the bottom of all of our minds, and it's connected. It's one self, but that each one of us is like a different, like sort of a fractal emanation of that one self. And that the space-time universe unfolds out from within the implicate order, while the information within space and time flows back into the implicate order. Here's a little more complex diagram showing the same thing, a cybernetic loop projecting the universe. So you see that in this middle here would be the Fourier transforms. Whoops, I got to go back. And the one arrow going from the implicate order to space-time, that indicates that holoflux is projecting the universe into space and time. But all the information that's occurring in space and time then flows back into the implicate order and informs it. And at that point, we actually see a feedback loop. So here's the feedback loop of the universe. I'll go back one more time. This large diagram is shown in the next image at the very top here. So that's happening here. It's projecting the cosmos, and then the cosmos sends information back into the implicate order, perhaps through gravity, because physicists still don't really understand the ontology of gravity. Why does gravity suck things back toward the center? Maybe that gravity is modulated with information that is then used by the implicate order to, after it analyzes it, repeats the whole cycle, as we've shown before in the previous slide, of the Planck time constant going in and out. So how do the hidden dimensions within Bohm's implicate order project the cosmos into our space-time universe? Universe store information. This would be something that Pribram was most interested in. How is information stored in our universe? One idea is called the Bekenstein bound, a proposal in 1970 by a graduate student of John Archibald Wheeler. As I mentioned Wheeler before, he coined the term black hole, and he drew that cute little U diagram of the universe looking at itself. But Jacob Bekenstein pioneered the mathematics of what's called black hole thermodynamics. And Stephen picked up on this and was very interested in it. BIT as the smallest possible storage area in space, having an area of 1 square Planck length. As you recall, the Planck length, nothing can be smaller, so the qubit is the space-time universe. Information that can be contained upon the surface has come to be known as the Bekenstein bound. So it's the number of bits that can be stored on a shell of a given radius. What we call these spherical shapes isospheres. And frequency, according to electrical engineering, a wavelength would be the diameter of the isosphere. So that every isosphere would have a unique wavelength and frequency, which means you could probably address it. You could, if you had the right technology, you could tune into it. Each frequency resonates with the same corresponding frequency within the implicate order. That's really the key, that the same frequency in space-time, electromagnetically, would be the same frequency within the implicate order, resonating with these other hidden dimensions. And note the grid again. Each rectangular grid is a single qubit. Here again, we see a quantum black hole, or the Planck holosphere at the center, Fourier implicate order, that has all these other dimensions, these transcendental dimensions. So here's an example, quite a different example, but it would just give an idea about how much information might be carried by a red blood cell on the spherical surface, more or less spherical, of a red blood cell. This might be appealing to people who consider blood as an important conveyor of consciousness. I think people like the Aztecs and some religions believe blood is really important. So let's examine the possible storage capacity of a red blood cell, an erythrocyte. These cells are really mysterious. Although we know about red blood cells, when we bleed, we see the red blood. They have no nucleus at all. Each blood cell, they don't reproduce. They're actually generated in the bone marrow, and they're found throughout the body. And if we consider the diameter of a typical blood cell, it's about 10 microns. And if you plug them up with 10 to the 60 bits, 10 to the 60th bits in red here, that's the storage. That's a lot more than, a 3 gigabyte computer hard drive. That's enormous. In fact, by comparison, has a reported capacity of 10 to the 18 bits. 10 to the 18 bits, which is a lot smaller than what they could store on a blood cell if they knew how. Well, that's kind of interesting. So how do electromagnetic waves enable communication? Now that we have a possible way of storing information in electromagnetic shells and spheres, how do we actually communicate? How might human beings communicate with infrared or ultraviolet radiation that our bodies put out? In fact, recently, physiologists have discovered that cells in our body do put out some ultraviolet radiation, and they don't know why or how. It's much shorter wavelength than infrared. It's a different bend, but it still has the potential of communicate. How might human brains communicate with invisible dimensions? Here's classical antenna theory that all amateur radio hands know about. Although, we almost always show electromagnetic fields as sine waves on two-dimensional pages, which is not the ontological reality at all. But we're used to seeing sine waves this way. And what you can see is that a wavelength, the difference in length in space between two peaks, has a voltage differential between the peak and the trough. And this is really important in designing antennas, because you want to design an antenna, a physical antenna, to be that wavelength. So it will resonate with the frequency that we want to either send or pick up. Here's a picture of an iPhone antenna. Even iPhones have an antenna. And it's inside your iPhone. If you want to break your iPhone apart, you'll find the antenna. And here's a spectrum of different frequencies. And this shows where your iPhone is on the spectrum. Actual radiation is multidimensional. So quantum mechanics and mathematics supports the idea that actual energy frequencies manifest in multiple dimensions. It is likely that frequencies manifest in all of the 11 dimensions of M theory, or all of the 10 dimensions of string theory. In the three-dimensional space, however, we can visualize waves of nested spheres moving out from our antennas at the speed of light. The wavelength is comparable to the spatial distance between two nested spheres. Actual radiation is really complex, much more than the sine wave diagrams we learned about in high school. And they're three-dimensional, they're spherical. You can see them in the waveguide. This is a waveguide below. In fact, radiation travels well within a waveguide, which, by the way, might be found in human capillaries, or perhaps in the cavities of microtubules, very, very tiny channels within the human body, within most nerve cells. The cross-sectional size of a waveguide cavity encourages the waves to maintain its shape from peak to peak, and it keeps it within the waveguide, keeps it from being interfered with from outside signals. So our modern internet data highways are fiber optic waveguides within which flow waves at the infrared frequency. Now, that's quite interesting, since humans put out infrared radiation. Also, our internet uses infrared frequencies and radiation. And most of these internet systems are generated by carbon dioxide full of carbon dioxide. Duh. They may also act as waveguides at carbon dioxide laser frequencies in the infrared. Now, very little of this is being explored by modern science. At least I haven't picked up on it yet, possibly because there hasn't been much funding for it. It's way out on the edge of science, where money hasn't yet flown, I guess. What might be the range and peak wavelength of human consciousness? Well, that's an interesting question here. At what wavelength region should we search if we were searching for human consciousness in electromagnetic waves? It would be much higher than radio waves. I think it's about 10 to the 3 meters. That's pretty big. That's like, I guess, a kilometer. Yeah, that's a kilometer wave. That's a radio wave. And the frequency is 10 to the 4th hertz. So you can have higher frequencies. They get, here we are. Microwaves are about 10 to the -2, about a centimeter maybe. Human electromagnetic radiation, I've already talked about. It just keeps jumping ahead here. Is around 10 to the -5th. That's the wavelength of infrared electromagnetic radiation that comes out of our body and flows through our capillaries. Then there's visible light. Light is actually visible electromagnetic radiation. It's only visible because we have specially designed eyes and systems that pick up on it. And then it lets us call it light. But it's electromagnetic waves. Even smaller is ultraviolet waves, which are found around molecules. Molecules emit them. And we actually use those in science to determine what kind of molecule. X-rays, we use them with atoms. They're extremely small waves, and they can hold a lot of information if we knew how to encode the waves. And then gamma rays, we can't do anything with. We can barely detect gamma rays, but our science technology has yet to develop a gamma ray radio. So that's for the future, I suppose. But in other words, the higher the frequency occurs, as the spatial dimension shrinks in size. See that the spatial size in space is shrinking, but at the same time, the frequency is increasing. And as we go up to higher frequencies, there's more energy and there's more possibility of encoding information at smaller dimensions at higher frequencies. So I'll just pop back. This entire image is shown at the bottom, is shrunk down quite a bit, and it's shown in the next image at the bottom, down here. So what I've done is I've expanded the range from radio waves all the way to the diameter of the universe at 10 to the 27 meters. And that would be equivalent a wavelength of 10 to the minus 19 hertz. And at the higher end, as we get higher, smaller and smaller, higher frequencies and smaller wavelengths, we go all the way down to the electron, which we've talked about in other slides. And then this long unknown region, it's like the, when the early sailors were trying to sail their ships out into the Atlantic to find China, they didn't know what was out there. They thought there might be dragons and things. But anyway, we can't really see this area, these tiny, tiny areas below the electron. But we do know from quantum mechanics and the math that proves it, that the bottom of this is the Planck length, the lower limit of space. Now I come to, this is actually a picture of a radio that I have. It's not just a radio, it's a transceiver. The transceiver can both receive and broadcast electromagnetic radiation. And we use this to communicate. I've used it to communicate with a Russian station in Antarctica. No, I'm not a spy, but they have ham radios down there with only 5 watts. So you don't need much energy, much power to communicate if you tune in to the right frequency. The dial on this radio now shows it's tuned to 7.073 megahertz, which is right about here. And remember, our bodies are putting out infrared, so if I had a transceiver at the infrared, I'd be able to tune into my own heat or radio waves in the infrared. And then this is really a very fascinating device. It shows the time display and the frequency domain. So again, we have the Fourier transform. Now that you're experts on the Fourier transform, you know about the frequency domain and the time domain. And you can see them here on the screen of this transceiver. And the frequency domain in the implicate order is just pure frequency. The time domain go to other radios in other parts of the world. Now, what is this? This is the brain. And what I'm saying here is that the brain may be acting like a transceiver. Not a hand transceiver, but it's a brain. And you might say it's a state-of-the-art, high-frequency bio-electromagnetic transceiver, a human brain, which allows the brain to filter and tune into various other frequencies. That's what I propose and what Pribram and Bohm propose. And we know that human frequencies peak in a narrow range in the infrared at 700 tetrahertz, which is really high frequency, which you need a high frequency in order to think. Our thinking takes much more computer processing time than our computers, because we can, even when we dream, we think we can see things and make up stories or tune into colorful dramas that go on in our brain. That must take a lot of processing power. So this actually brings me to the end of my presentation. You can breathe a sigh of relief as I assume your brains have been stretched a bit. And final look again at the electromagnetic radiation being broadcast from a human body. With an output of about 860 watts, the human body is easily visible in the dark using night vision goggles tuned to the infrared spectrum of the electromagnetic energy world. Might there not be other ways that infrared radio communicating with other dimensions? How do our pets seem to know we are coming home when we are still miles away? And what are all the reports of telepathy and paranormal modes of perception? Perhaps time will tell. We're at the very primitive beginning stages of understanding consciousness. And though the human body puts out about 860 watts, depending on your metabolism, the heart itself puts out 1.6 watts with every heartbeat. So here's a final chart to strain your brain, maybe, I hope not. The first line shows energy radiated by the most powerful radio on the planet, which happens to be a Christian radio station broadcasting from Mexico, where they don't have limits on the transmitter power. That station puts out 1.5 million watts of power, radio wave power, electromagnetic power. And then the center line, the energy radiated by the 3 Mile Island when it was running at its maximum capacity, 873 million watts. But if you consider right now on this planet, every human heartbeat is beating along with yours, putting out 1.6 watts. It doesn't sound like a lot, but if you multiply by 7 billion, we come up with 9, what is that? I can't even say it. A little over 9 gigawatts of energy being put out. All that energy is being dumped into our environment, and maybe it's being picked up by people who are sensitive to telepathy, or maybe the CIA, or who knows. There may be technology beyond what we can imagine. I don't want to start a rumor here, but I think we're in an amazing time in our planet and in our technology, and we'll see some amazing developments in the near future. Finally, and colleague, Brian Swim. Dr. Swim is a professor at the California Institute of Integral Studies who earned his PhD in mathematical cosmology. And he has often said that, quote, "Radiance is the primary language of the universe. And this radiance emanates from us and out into the universe at every moment of the day, especially when we pray, meditate, and contemplate the wonders of our universe." So thank you very much. I think that's all I have to say. I'd also like to thank the Foundation for Mind Being Research that made this possible. Here are a few of my books that explore these ideas further. They're all available at Amazon. Many of them are on Kindle. You can find also other interviews recorded and more material on my work on my website, www.shellyjoye.net. So that's all from me.
Great. Thank you. Thank you so much. I already have some questions, and I want to let people know if you have questions. I'm sensing that maybe some of the questions might be fairly complex. So if you'd rather not type them in the chat and you'd rather just raise your hand and ask them, just go down on that lower bar and raise your hand, and I will unmute you and you can ask. But we do have a couple of questions so far. Daryl wants to know if you're familiar with Robert Lanza's series of books over the last 10 years or so regarding biocentrism. He said they seem to posit that the universe out there is really inside us, so to speak, and you seem to be positing a similar thing. Can you relate to the work of Robert Lanza, and are you familiar with it?
Yes, I do have one of his books, and I've read it, and I think I pretty much agree with him with his viewpoint. It's very hard to tell whether we're looking out or in, but the whole universe, I do believe, is connected biologically and consciousness-wise, and it's so mysterious and so powerful. I think we're just scratching the surface. So yeah, he's got some really good books, and it's quite accessible to read, I think.
I think that's a really good point about us being sort of really at the beginning here. It feels that way. So Vince has a question. I'm going to unmute him. So go ahead, Vince, if you want to unmute yourself and ask your question.
Yeah, I don't know if you can hear me or not.
We can.
You can? Okay. Question for Shelli. I've written her a couple of letters. I was hoping she had information on the EOST project that I was working on. It stands for Exponential Operating System.
Yes, I have read it, and you've done some amazing work, I think.
Well, thank you. Okay.
I haven't had time to really answer you in detail, but appreciate it. And I will try to take the time to answer you at some point. But I hope you can get it out there. Maybe do some kind of a YouTube video, perhaps.
I've got a friend that works at NASA named Zion Martin, and she's going to get some funding for me. I've already sent her a couple of videos of how the thing operates. We're looking at the possibility of interchangeable panels with fractal algorithms that would kind of boost or reinstate some sense of consciousness, maybe not in the order of intelligence like what I've been talking about, but more for peace of mind and harmony. So if this goes through, it kind of goes, when I turn a page that I took notes of the whole thing today. By the way, you did an exceptional job. Thank you. There's this man by the name of Dr. Adam Gazzulli, UCSF. He runs a thing called Neuroscape. I don't know if you've heard of it down there. It's done through virtual reality. And I've written him a couple of letters on the UST as well, potentially to become a training device for the UST at some point. So when we get time, we'll share information. I'll get you the feedback from what he says, and I'm going to get a tour of the facility at UCS, University of San Francisco as well. But again, not to take up too much time. Thank you for your efforts. It's nice to hear your voice, and I live in Penn Valley. I'm not that far away. Thank you.
Yeah, thank you.
You're very welcome. Yeah.
Yeah, you're up in Penn Valley, so a lot of people being really affected by the fires. Dawn wants to know, so basically what you're saying is that the implicate projects to the explicate and then views itself as a mirror image?
Yes, I would say to some extent, yes. There's a certain randomness in space and time. And I have to say, I think the implicate order is part of the cycle. We can even call it God or some divine force that we are all part of that's creating this beautiful creation we have. But there's some flows through space-time when things happen, goes back into the implicate order, where since there's no time, there's like an immediately enormously fast, you might say, although fast is this iteration of the universe is then broadcast out or projected into the universe. David Bohm talks it about, explains that he uses the terms folding, infolding, and enfolding, that the universe is unfolding from the implicate order outwards, and at the same time, things that are happening is folding back into the implicate order. So one of the corollaries of this is that everything that happens in space-time is stored forever in the implicate order. There's unlimited storage space for the frequencies, dynamic frequencies that occur in space-time. So all of our lives, every minute, everything is being recorded. I don't think it's a malicious recording. I think it's there, and we may discover ways of accessing it when we leave our biological bodies. But that's, as I say, another. It's getting close to science these days.
Thank you. So Dimitri wants to know, Dimitri says, fascinating as always. So thank you. I'm wondering, what is the meaning of our gradual discovery of what the conscience is, if we are the knowledge itself to begin with? Perhaps we are not supposed to ask that? That's the question as written.
We're not supposed to ask that. I think it's okay to ask that. I think God gives us, or the universe gives us, the freedom to explore all kinds of things in a creative way. And one aspect of creativity is trying to understand and build creative models of what's going on. A lot of these models have been developed by different cultures in their religious teachings, their religious practices, as ways of understanding the universe. And I have to say that all religions, I think, are really kind of works of art. And they're also like flowers. I wouldn't want one flower to dominate every other flower and say, oh, my flower is the only real flower. I think all the others should fade away. I think all flowers, religions, and cultures and people are beautiful, and they're being created and projected into time and space by this enormously complex, powerful implicate order that we're just beginning to understand. Of course, knowledge can be used for evil things, I suppose. We have good and bad, but they're just aspects of reality. And I think, like the Greek plays, they had comedy and tragedy. They had a smiling mask and a really sad mask. It's all part of creation. And I don't think knowing more is a bad thing. I better stop there.
Totally agree. Well, one of the things that you said, you mentioned the task of the 21st century is to unite science and religion, or I'll say science and spirituality, which I totally agree with. And there's so much of what you're saying in the scientific view that dovetails so beautifully with really ancient wisdom traditions that you've studied, which I think is why it's that great partnership between it was Krishnamurti and David Bohm. Where do you put free will in all of this?
Well, we're all like little emanations of the one. I think free will exists at every level, pretty much. I think that's the beauty of it. I think I don't know what else I can say, but free will. There are some religious viewpoints that everything is preordained and God calculates everything, but I think the fact is more richer than that. That even the smallest animal has free will to do various things, and every star and every galaxy, I believe they all have a certain type of consciousness that resonates at unique frequencies in the spectrum, and everything in the universe is doing its thing, and yet it's all connected. It's almost like a painting. Working on a painting, you always say our stroke of your hand, or even the whole theme of the painting. So I think if you want to call it God or the implicate order, it delegates a lot of this creativity to each one of us, and not only humans, but to animals and minerals. That in geology on the planet Earth, new minerals are constantly being formed in volcanoes. I mean, minerals that have never existed before on the planet. So it's almost like you could say that God is an amazing scientist who's exploring creativity through us and continually trying new things. It's mind-boggling. That's all I can say.
It's mind-boggling, and it's a very exciting worldview. It's I love that just sort of cauldron of creativity that it evokes. So I want to thank you. I don't think there are any more questions, and I want to thank you for being here. Can you put up your website again? The website is shellyjoye.net. Is that correct?
Oh yes, it's shellyjoye.net. Yes.
Okay, and so you can find
www. Yeah.
And more information and some of her interviews. And I just want to thank you again for this really amazing presentation. And I hope that you stay safe from the fires, and that everyone stays well and has a great rest of the weekend.